Okay. Now, what are the questions? Homework questions, chemical kinetics. Kinetics. 2A plus B converted to B. Converted to product. Order with respect to A is 2 and order with respect to B is -1. Now write rate law expression. Second is total or overall order of reaction. Okay, this one. Now, how can you solve this one? Rate law expression, how can you write? R rate constant, order with respect to A is 2, A square, B to the power -1. That is the first question. Now, what is the total or overall order? Overall order is 2 minus 1 equals to 1. Third, what will be the effect on rate if concentration of A is doubled? Effect on rate if concentration of A is doubled. Okay. Now concentration of A is doubled. How can I write? Answer, how can I write? Rate proportional to concentration to the power order. Okay. 2 square. So we can say 4 times. So we can say rate increases by 4 times. Rate increases by 4 times. Fourth one. Fourth question. What was the fourth question? Effect on rate if concentration of B reduced to 1/3. If concentration of B reduced to 1/3. Okay. Now, how can you solve? Again, same thing. Rate proportional to concentration to the power order. Now, in this case, for B, what should be the order? Concentration becomes 1/3, order is 1 to the power 1. So we can say 3 times. So rate increases by 3 times. 3 times increases. Is it clear? And last was, what will be the effect on rate if volume of container is doubled? Fifth one. What will be the effect on rate if volume of container is doubled? Container is doubled. Okay. Now, we all know that Rate inversely proportional to change in volume to the power order. Rate change in volume 1 by 2. What should be the overall order? Overall order is 1 to the power 1. So rate becomes half. Okay. Any doubt regarding this question? Tell me. Do you have any doubt? This one is clear. Okay. Question number 1. That was homework. Now question number 2 and 3 you have to solve. Question number 2, 3, 4. Giving you after that question number 5, which is little bit tricky. Question number 2. A converted to product is given. Okay. Now what is given? Rate becomes half. If concentration of A increases by 4 times. Now determine order with respect to A. Determine order with respect to A. Solve it. Next question, question number 3. B tends to product. Okay. If concentration of B triple, rate increases by 9 times. Increases by 9 times. Find order. Okay. Question number 4. A plus B changes to product. Now for A, if concentration of A double, rate becomes 4 times. Concentration of B triple, rate 1/3. Find overall order. Solve it. 5-minute time giving you. 5 to 6 minute time. Solve it. Completed. I hope all of you completed this one. How can you solve? Again, same thing. Formula is same. Rate proportional to concentration to the power order. Order I am taking n. N is order. Now rate increases by rate becomes half when concentration increases by 4 times. So 2 to the power minus 1 equals to 2 to the power 2n. So 2n equals to minus 1. What should be the n value? N value equals to minus half. Is it clear? Okay. So order is, what is order? What is the half order reaction? Negative half order reaction. Now rate increases by 9 times. Again, same formula, rate proportional to concentration to the power order. Rate 9 time increases, concentration increases by 3 times. So 3, 9 you can write. So what should be the n value? N value is 2. So order is 2. Okay. Now for in this, if you consider about the A stuff, so rate proportional to concentration to the power order, rate becomes 4 times, concentration is doubled. What is the n value? N value is 2. Now order with respect to A is 2. Rate again same theory. Okay. Rate becomes half, concentration is 3 to the power m. M is order with respect to B. So 3 to the power minus 1 equals to 3 to the power m. M is minus 1. So order with respect to B is minus 1. So what should be the overall order? Overall order is n plus m, which is 2 minus 1 equals to 1. Okay. Now next one. Okay. Any doubt? Do you have any doubt? Okay. Do you have any doubt regarding this part? Now next one is one of the tricky questions. If you compare this one is little bit tricky as compared to other stuff. Okay. Now again same theory, and this particular determination of order of this particular stuff, this type of questions is important. The question number 5. Here instead of 2 reactant, here 3 reactant is given. A, B, C converted to product. Now on doubling the volume of container, rate decreases by 8 times. Second, on doubling concentration of A and concentration of B to half. Okay. Rate becomes 4 times. Rate becomes 4 times. Third, on increasing concentration of C by 4 times, rate increases 64 times. Now determine just a minute. On increasing concentration of C, volume of container. Okay, determine order. First question, order with respect to A, B, and C, and determine overall order of reaction. Overall order of reaction. Okay. Now try to solve it. Okay, giving you 5 minute time. Solve yourself. Okay. Completed. Now, how can you solve? Just check. In this case, we all know that rate, which is directly inversely proportional to change in volume to the power order. Now order, we are taking P plus Q plus R. Okay, overall order. Okay, now P is order with respect to A, Q is order with respect to B, R is order with respect to C. Now rate decreases by 8 times. Volume becomes double. Overall order, can I write P plus Q plus R? This 2 to the power 3 equals to 2 to the power P plus Q plus R. Now P plus Q plus R, we can write 3. Okay, we can write 3. So what is the overall order of reaction? That becomes 3. Now you have to find determined order with respect to A, B, and C. Now doubling the concentration of A, half reducing the concentration. So we can write same formula, rate proportional to concentration of P into concentration of Q. We can write now rate becomes 4 times when concentration of P is this one, concentration of Q is this one. Now 2 to the power 2 equals to, can I write 2 to the power P, 2 to the power minus Q. So P minus Q equals to 2, equation number 1. And in this equation, increasing the concentration of C, rate increases. Rate proportional to concentration to the power R. Okay. Now rate increases. Rate increases 64 times. Concentration. Rate increases 64 times. Concentration of A on increasing concentration of C, sorry, by 4 times. That means 4 times. So 4 to the power 3 equals to 4 to the power R. R equals to 3. Now P plus Q plus R equals to what? 3. Where R equals to 3 means from here you can write P plus Q equals to 0. Now this one is the equation number 1. This one is the equation number 2. When you calculate this one, 2p equals to 2, p equals to 1. Now what should be the q value? Q value is -1. So order with respect to A is 1. Order with respect to B is -1. Order with respect to C is 3. Is it clear? Any doubt regarding this part? Tell me. Okay. Another two types of question, different types of questions. Question number 6. Rate expression of a certain reaction depends on concentration and minus dc by dt, which is k1c 1 plus k2c. Now determine order and rate constant of reaction. When concentration is very, very low, very, very high. Okay, solve it this one quickly. And question number 6. 2a changes to B product. Simple reaction is given. Now R1, K1, A square, 4A plus 2B changes to product. R2 equals to K2, A to the power X, B to the power Y. Derive relation between K1 and K2 and determine value of X and Y. Okay. Now solve it, giving you again 5 minute time. Completed. Now in this case, what is given? Concentration is very low. That means C is very low. C is very low. First one. C is very low means C tends to 0. If C tends to 0, we can say K2 into C tends to 0. So 1 plus K2 into C tends to 1. So what is minus dC by dt? K1 into C. Very high. C is very high. Okay. C tends to infinite. 1 by C tends to 0. Minus dC by dt, which is equals to K1C 1 plus K2C. K1C by C, 1 by C, K2C by C. So just cut down all the stuff. So what you get? K1, 1 by C plus K2. Now 1 by C value is 0. So we can say minus dC by dt, which is equals to K1, K2. Now in this case, how can you find out order? Concentration to the power what? Nothing is given means concentration to the power 1. And this one is a rate. So rate equals to K. K means rate constant into concentration to the power 1. So order is 1. In this case, this one is a dC by dt, which is equals to rate. Nothing is given, we can write C to the power 0. C to the power 0 means 1. So this 0 should be the order of reaction. So here order is 0. Now at very low, very low concentration, order becomes 1. Very high concentration, order becomes 0. Is it clear? Any doubt? Do you have any doubt regarding this part?
No, sir.
Okay, this stuff is clear. Second one, solve it. This part. In this case, A plus B converted to product. Now here nothing is given. What is changing? What is the difference between these two? Thus just stoichiometry increases by two times. Both cases. In this case, stoichiometry is 2A plus 2B. In this case, stoichiometry of reactant is 4A plus 2B. So stoichiometry changes by 2 times. So from here we can say, from the first equation we can write rate equals to 1 by 2 minus dA by dt. This one is given K1 A square just a minute. B to the power 1. Just a minute. Okay. Now in this case, what we can say? Minus dA by dt, which is equals to 2 into K1 A square B to the power 1. This one is the first equation. Now from the second equation, we can say rate equals to 1 by 2 minus dA by dt. Instead of 1 by 2, you can write stoichiometry is 4 dA by dt, which is equals to K1. What should be the equation? Equation in this case, power should be the 2, because simple reaction is given. Simple reaction case, order should not be changed. So x value is 2, y value is 1. Now what is the relation between K1 and K2? In this case, we can say this one is a K2. So rate equals to 4K2. Here rate equals to 2K1. Okay. So 2K1 equals to 4K2. So K1 equals to 2K2. Is it clear? Is it clear? So relation between K1 and K2 to K1 equals to 2K2. Is it clear? Any doubt? So 2-3 point just remember regarding this part. Just a minute. Okay, just write down some important point. First important point, example of some reaction. Suppose we can write 2O3, 3O2. In this case, rate equals to, can I write O3 square O2 to the power -1. So reactant and product both can appear in a reaction. Next is, we can say 2SO2 plus O2 catalyst, which is NO2SO3. We can write 2SO3. So rate equals to, we can write O2 to the power 1 NO square. So catalyst also appears. So from here we can write some important point. Point number, note. In this note, you have to write down some important point. Rate law expression, RLE, involves reactants, also in some cases product and catalyst also appear in rate law expression, but product, but remember intermediate step, mediate step can never appear in rate law expression. Second, for simple, another name of simple is elementary reaction. Order of reaction is directly proportional to stoichiometry of reaction. Okay. Third, you can write on changing. From here we can write another thing, rate law expression. Another thing, just write down order is an experimental property. Mental property. But stoichiometry of reaction is in the hands of ours. That means stoichiometry can be changed. Okay. Fourth one, on changing stoichiometry. Last point, on changing stoichiometry, rate of reaction can change. But rate of particular substance is not dependent on stoichiometry. Okay, and that is the end for today. Is it clear? Any doubt? Do you have any doubt regarding this part? Tell me. This part is clear?
Yes, sir.
Okay, so that is the end for today. Bye all. Take care.